All right, guys, so today we're on page 14 of your notes. We're going to be doing piecewise functions. So what a piecewise function is it's a function that has different rules depending on what part of the domain you're in. All right, so like a really good example of that is if you lease a car. All right, so let's say it's $199 a month. So f of x is our cost as a function of miles. Maybe I should have used different variables there, but that's all right. So the function says that if we drive less than or equal to 100 miles, it's just a flat rate of $199 per month. But if we go over that 100 miles, now we're paying the $199 plus 25 cents per mile over the 100. Now, the thing that we're going to talk about a lot today that you need to be aware of is this. Notice how I didn't have an equal to on both of these. So we still have to maintain our rule of what a function is. Each input can only have one output. So that less than or equal to the 100, if I say we drive exactly 100 miles, I know that I need to be using this rule and not this rule here. So that's what a piecewise function is. All right, so next page, we're going to do a little bit of review. This is something you've done a million times for letter A. For letter B, maybe not. But we're going to write the equation of this line. So slope of -2 through the point 1, -4. So slope intercept, we have our y equals mx plus b form. And yeah, we could graph this. We could put the point 1, -4 on our line. We could count up 2 over 1, up 2 over 1, up 2 over 1 to find the y-intercept. And that would work great as long as the y-intercept is a nice whole integer. If it's not, then we do a little bit of algebra like you guys have done, a ton earlier in your past math years, where I can plug in the information that I know. So I know the y-coordinate is -4. I know the the slope is -2. I know the x-coordinate is 1, and then we are trying to solve for the b value algebraically. So we have -4 equals -2 plus b. B equals -2. So now I can write the equation of this line, y equals -2x minus 2. All right. We also have this point slope formula. So this might be a new formula for you guys. Some of you probably seen it, some maybe not. But it looks like that. Y minus y1 equals mx minus x1. The m is still the slope. And the x1 comma y1 is your xy coordinate. So basically we're plugging in, we're substituting these three things. And it's really quick and easy. It's exactly what it sounds like, point slope. If we have a point and we have the slope of the line, we can use this formula really quickly. All right, we don't know the intercept in this case. So what we're going to do is we're going to plug it in. Y minus the y coordinate, which is -4. So we have y minus -4 equals m, the slope, x minus the x coordinate, which is 1 in this case. So we know we can simplify that a little bit. This turns into a y plus 4. And if you were to write this to another math teacher, y plus 4 equals -2x minus 1. Well, not necessarily a math teacher, but anyone who's familiar with this formula, that's a perfectly acceptable way to write this line. All right, so we have the slope, -2. We have the coordinate 1, -4. We could also kind of check our work. I could simplify this, subtract 4 from both sides, distribute my -2 through, so that becomes -2x plus 2. I subtract the 4, and it actually, not surprisingly, works out to be the same equation as here. So that point slope formula is helpful if you don't know the intercept, the y-intercept, and also if it's not a nice integer y-intercept number. Let's say the y-intercept was like 1/2. That would be helpful there as well. Okay, moving on. So piecewise defined functions. A piecewise function is defined by different formulas or different rules for different parts of its domain. So what I have here is a nice example of a piecewise function. So let's say we're just evaluating these numbers. F of -4. -4 is, this is my f of x. That's basically my input. So I look at which part of the domain we need to follow here. So -4 falls in this topmost domain. So the rule is x squared plus 2x if x is less than or equal to -1, which it is in this case. So I plug in -4 for my x's, and that's the rule that I'm following. So we have 16 minus 8, which is 8. All right, I can do the same thing for -1, for 0, and for 25. So -1, we have to be careful here. That's why this equal to sign is very important. So -1 actually also follows the first rule. So -1 squared is 1. I guess I'll write it all out again. Plus 2 times -1. So we have 1 minus 2. So my rule, if I'm looking at f of -1, my rule is x squared plus 2x, and that gives me an output of -1. F of 0, 0 falls in this middle domain, so f of 0, we just plug in 0 for x, so this is equal to 0. And f of 25, that clearly falls into my last domain, so the rule is f of x is actually just a constant, it's just -1 anytime x is greater than 1. So this, nothing to substitute, we just know that's the rule. So that's how these piecewise defined functions work. We're going to be graphing them, we're going to be writing the equations from graphs, so not a lot of stuff that you haven't done before. So what I'm going to do here is let you guys work for a minute, and then I'll show my answer. So the following graph represents a piecewise function. So what is the function that corresponds to this graph? So really we have 3 different chunks, and the thing you have to be careful of, there's my 3 different lines, is that between each function there's like a brick wall. So that function starts and stops at those values. So we have to be really careful when we're out restricting our domain. So what I would do for a few minutes is just practice our equation writing skills. You can try that new equation I gave you at the top. But we're going to write the equation for each one of these lines. So you can count the slope. Hopefully that, if they all land on nice perfect y-intercepts, that would be great. But go ahead and pause, write the equation of those 3 lines, and then when I unpause, we'll kind of put it all back together and write it out in a piecewise notation. All right, so go ahead and do that now. All right, so I know I'm in a different document here. I actually had this work done, so I'm going to save myself a little time. So hopefully you can follow along with my work. It's a little bit kind of all over the place, but I wrote, for each little line here, I kind of noted the slope and a point on that line. Slope, line 2 is a nice constant, and line 3 up here, the slope was up 3/2, and there's a point on that graph at 4,3. All right, so if you use a different point, I know it was a little hard to see on your note packet, so if you use a slightly different point, don't worry about it. I just wanted to make sure you kind of followed the process. So for line 1, I think I just went down 1/1, down 1/1, down 1/1, and that's how I found the y-intercept here. For the line y equals -2, that was just a constant right here. And then the last line, I wanted to use my new formula just to try it out. Here are the 2 formulas that we could pick from. I just used my new formula just to practice. So the point was 4,3. The slope was up 3/2, up 3/2. So if you miscounted that slope, that's okay. But I came out with a formula of y equals 3/2 x minus 3. So to write this into a piecewise function, we have f of x equals. And now I just want to write each rule depending on what part of the domain it covers, what part of the domain that it's in. So for the first part of my piecewise function, it happens up to, but not including -3. So notice the open circle right here. So everything up to, but not quite including -3, I follow the rule -x minus 2. And then starting at -3 up to +4. So again, we're looking at the x values in my domain. So from -3 up to 4 for the x values, it's a constant. I just use the rule f of x equals -2. And then the last part, starting at -4, right at -4, I use the last rule, y equals, or f of x equals 3/2 x minus 3. So we're just looking at each individual part of the domain, and we are writing the rule depending on kind of what part of this graph is active within each part of our domain. I don't know if I said that really well, but hopefully that makes sense. We're just chipping away. We're writing one equation at a time, and just depending on what part of the domain we're in. So if you have any questions on this, we will be spending a lot of time practicing next time I see you. If you want to try this next one out just for some more practice writing the equation from the graph, there is the work for this one. Let me bring my shade down here. So again, I took the three pieces. They're not always going to be three pieces, by the way. I looked at what part of the domain each chunk of this graph was active. And for that third graph, it may be a little hard for you to see the points, but there's the work in green here for that third graph. It does not have a nice integer y-intercept, so I did the point slope form to find that equation. All right, so if you want to pause and try that one on your own, you don't need to unless you feel the urge. So last thing we're going to do quickly is draw the graph of one of these. So you can see again our rule. It tells you which part of the domain each rule is active in. And we're going to get later in the year into a lot more graphing without our calculator. I know you guys can all punch this into your calculator and get this graph pretty quickly. But what I did is I just made a little table of values for each part of this function. And then the important thing to remember is that this graph goes up to -2. All right, so it's going to go all the way up. If we think of this as a little brick wall, it's going to go all the way up to -2, but just have an open circle right at that point. All right, we don't stop at -1. So my table of values, let's see if I can get it. There we go. My table of values, that first part of our function, I just started at -4 to -3 to -2. We need that -2 point plotted for this part of our graph because that point does need to be on our line. It just has an open circle there right at -2. All right, so I hope that makes sense. So if you want to take a minute and do these three table of values on your own, you certainly can. I think we're probably okay with that. Just be really careful if, for any negatives, if there was like a -x² there, we have to be thoughtful about that. But there are my table of values. And you don't need these lines. I actually probably wouldn't draw them there that I'm putting on the graph, but that just helps me visualize my graph. Each chunk of this graph, each rule has to stop at that point. I don't graph -x plus 2 and make it go all the way through. And then I don't graph the x² minus 2 and make it go like this, because that wouldn't be a function. We need to have a vertical line test still. All that stuff still matters. But let me unwind this. You guys can graph this on your own. But I can just plot a couple of these points. So I know -4, 6 is on my graph, -3, 5, -2, 4. I think I missed those. You know what I mean. Let me get rid of those. All right. -4, 5. This is fun watching me graph. I'm going to pause after this one, and you guys can do it on your own. Did I do it right that time? Yeah, I did. So that last point, that needs to be our open circle, because right at -2, this graph doesn't happen. But I still need that point there because it does exist at -2.00000001. All right, I think I did it again, didn't I? I got to move that all up. All right, I'm going to pause. You guys can sketch this graph on your own, and when you unpause, I'll have my answer. Just to make sure we're all on the right track, and we'll get some more practice with this next time I see you. Okay, so there's my graph. Just keep in mind where the open versus closed circles are. It all has to do with these inequalities here. So I had my closed circle, for example, here at 2 for the third part of my piecewise function here. All right, so you'll have your usual Google form to fill out after this, and we'll get a lot of practice time in this on class, and we'll finish up our notes. We're gonna have a little bit of notes to take in class next time on absolute value piecewise functions. Other than that, we're good. Let me know if you need anything from me, and I'll see you guys next time. Bye.